Hey, math enthusiasts! Today we're diving into the world of trigonometry to uncover a fascinating equation, sine 3x. Get ready to flex those geometry muscles and witness a visual proof that'll make you say, aha! Let's set the stage with a unit circle. Imagine a circle with a radius of 1 unit, where angles are measured from the positive x-axis. If we draw an angle of 3x, the vertical line segment opposite that angle represents sine 3x, and the horizontal line segment adjacent to it is cosine 3x. Now, here's where things get interesting. We can break down this sine 3x triangle into 3 smaller right triangles, each with an angle of x. These triangles stack on top of each other, like puzzle pieces, to create the full 3x angle. The goal of this geometrical derivation is to resize the sine x components of these triangles and fit them perfectly into the sine 3x side. Are you ready to see how it's done? Let's focus on the bottom triangle first. The opposite side, representing sine x, can be repositioned to align with the bottom vertex of the second triangle. To find its new length, we use similar triangles. By comparing the ratios of their hypotenuses and opposite sides, we discover the resized length is sine x cosine x. Moving on to the second triangle, we notice that its sine x side is slanted. To find its vertical component, we need to determine the angle at its top vertex. Using alternate angles and the fact that the sum of angles in a triangle is 180 degrees, we deduce that this angle is also x. This means the vertical component we need is sine x cosine x. By aligning this with the previous segment, we create a single vertical line with a length of 2 sine x cosine x. Again, by following a similar method as before, by moving this side to a position below the bottom vertex of the third triangle, and considering the 2 similar triangles with the vertex angle 2x, and equating the ratio of the hypotenuse and the opposite sides, we get the resized length to be 2 sine x cosine squared x. Moving on to the third triangle, we notice that its sine x side is slanted as well. To find its vertical component, we need to determine the angle at its top vertex. Using the same process of using alternate angles and the fact that the sum of angles in a triangle is 180 degrees, we deduce that this angle is also 2x. Hence, the vertical component is the cosine part of sine x, therefore its length will be sine x times cosine 2x. Now, by carefully arranging all these resized sine x components together, we miraculously unveil that their total length is indeed sine 3x. But we're not done yet. We want to express this equation solely in terms of sine x. To achieve this, we substitute cosine squared x with 1 minus sine squared x and cosine 2x with 1 minus 2 sine squared x. After some algebraic simplification, voila, we arrive at the desired equation. And there you have it, folks. The sine 3x equation, derived through a visual geometric journey. Pretty cool, right? Hope you enjoyed this video on the geometric derivation of sine 3x. If you did, please give it a big thumbs up. And if you haven't already, consider subscribing to the channel for more awesome content like this. Don't forget to hit that notification bell so you know when I drop new videos. Thanks for watching.